So this is the next section about adding, subtracting, multiplying, and dividing radicals. Okay, so the first thing that we're going to do is that we're going to start with add and subtract. So adding and subtracting. So the one thing that you really want to do when you're adding and subtracting radicals, what you really want to look for is like terms. Okay, so things that look like the same. And in this case, we're going to look for like radicals. So for example, if I have 3 square root of 3 and 3 square root of 2, these are not like terms because the radicals are completely different. This one has a square root of 3, this one has a square root of 2. So these are not like terms. This one, however, are like terms. So these are like terms because they have exactly the same radicals, square root of 2 and square root of 2. And usually when you're doing these, all you gotta do is add up the coefficients, so the number right in front of it. So for example, let's say we had 3 square root of 2 plus 4 square root of 2. All we have to do is just add up the 3 and the 4, which is going to give me a 7, and then we leave the square root of 2 by itself. So it's very similar to how you add variables, like if you were adding 3x plus 4x. Well, we don't do anything with the x's. The x's just stay, and all we just do is add the 3 and add the 4, and that gives me 7x. Okay, so that's basically the whole thing that you're doing. Okay. Now with these problems, we're not going to worry about the absolute values anymore. We're just going to assume that when you take the square root of x squared, this is just going to be x. Okay, so we're going to assume that x is just going to be a positive number, so you don't need to add absolute value anymore. Okay, so here's an example. So what I'm going to do is just add or subtract. Okay, so here is part A. So let's say we wanted to do the fourth root of 3xy plus 5 times the fourth root of 3xy minus 4 times the fourth root of 3xy. Okay? So the first thing that you want to look at is, are these like radicals? Do they all have the same radical? And the answer is yes, because this one is a fourth root and a 3xy, fourth root and a 3xy, fourth root and a 3xy. So that means I can add them together. So in this case, this one, there's nothing in here, but there's actually an imaginary 1. Okay, so let's start off with this one. 1 times the fourth root of 3xy plus 5 times the fourth root of 3xy is just going to give me 6 times the fourth root of 3xy. Okay, so that is going to give me that. And then I'm still left over with a minus 4 fourth root of 3xy. Okay, so 1 plus 5 gave me 6. Now I'm going to subtract it by this 4. So this is going to give me 6 minus 4 is just going to give me 2, the fourth root of 3xy. And that is going to be my answer for that one. Okay, so not too bad, pretty basic. Okay, all right, so let's try this one out. Let's try 3 square root of 5 minus 4 square root of 5 plus 2 square root of 5 minus 7 square root of 6. So why don't you try this one out and see what you can do, okay? And if you don't know, then I can just go ahead and do it for you. So first, let's go ahead and combine the ones that are like terms. This one is a like term, this is a like term, this is a like term, this is not a like term. This is completely different, so this one's not going to be combined with those other ones, okay? So this is just going to give me 3 minus 4. That's going to give me a negative 1. So it's negative 1 square root of 5. I'm left with a plus 2 square root of 5 minus 7 square root of 6. Okay, so these you can further combine. Negative 1 plus 2 is going to give me a positive 1 square root of 5 minus 7 square root of 6. Okay, at this point, you really can't do anything else. This is all that you can do because you cannot combine like terms. Two things that do not have... And you cannot combine things that are not like terms. So square root of 5 minus 7 square root of 6. These have different roots, so you cannot combine them. Okay? All right, so now let's try another problem. So let's say we have the square root of 20 plus 3 square root of 5. Okay, so let's say we wanted to do something that looked like this. Well, initially, it seems like you don't have like terms. but you can make it into a like term. Okay, can we further reduce a 20? Well, the 20 can further be reduced as 4 and 5, and then the 4 can be reduced as 2 and 2. So I can take out these 2's out into the square root, and what am I going to get? Well, I got 1 pairs of 2, that's going to stay outside. What's going to stay in the inside? Well, 1 5 is going to stay in the inside, plus 3 square root of 5, which is just this part. Now they have like terms. So sometimes you might have to simplify the radical a little bit more before you do the next step. Okay, so 2 and 3 is going to give me 5, so it's going to be 5 square root of 5. Okay, that's the answer for that one. Okay, so let's try a couple more. So let's say we have the square root of 40hb to the 5th power minus the square root of 75b to the 5th power. Okay, so first let's try to decompose this 48. Two numbers that multiply to get 48 is 8 and 6. Okay, so I can break this up as 8 and 6. Okay, here I can break this up as 4 and 2, and here 2 and 2. And then the 6 as 3 and 2. Okay, so I'm doing this because I can't quite decompose. They don't have like radicals, so let me see if I can decompose this into even more terms. Here the 75, 25 and 3 give me 75, and 25, 5 and 5 give me 75. So now we're looking for things that we can take out that are pairs. So let me rewrite it so that you can all see. So I have the square root. Okay, so I have a 2, a 2, a 2, a 3, and a 2. 2, 2, 2, 3, and 2. And then I have 5 b's. Okay, minus the square root. I have 2 5's. And then I have 1 3. And then I have 5 b's. Okay, so here I'm going to take out everything that's a pair. So here's a pair of 2's, and then here is another pair of 2's. So I have 2 pairs of 2's. So I have 1 pair of 2 and then another pair of 2. And then I have 2 pairs of b's. So I have b squared, square root of whatever's left over. So I'm left over with a 3 and I'm left over with a b. Okay, minus. Okay, I have a pair of 5's. Take it out. And then I have 2 pairs of b's, which I'm also going to take out. That's a b squared. And then what I'm left with is the square root of 3b. So 2 times 2 gives me 4b squared, square root of 3b, minus 5b squared, square root of 3b. Okay, all we got to do, now that they have like terms, I have a 4b and I have a minus 5b. So 4b squared minus 5b squared gives me negative b squared, and I'm left with the square root of 3b. Okay, and that is my final answer. Okay. All right, so there's really not a lot to it. Just you want to be able to simplify them if you see that there's not like terms. And then after that, that's try to add up the coefficients or subtract them, whatever you have to do. Okay.